Add to our stable of transformations of sinusoidal functions. We've talked about amplitude, we've talked about the period, and then of course related to the period is the frequency, although it's not actually a transformation of the sinusoidal function. It's just telling us how often the function cycles, the number of cycles over a given time interval. And now we're looking at a horizontal transformation which gives rise to the phase shift. Now, in this example here, we're seeing that we got a function which is the y equals the cosine of pi over 2 plus pi over 4, and that's in parentheses. And it's this pi over 4, or this c, if you remember, we got y equals a times the cosine of bx plus c plus d. And of course, a affects the amplitude. Now I have here graphed on the right, I've got in green is the parent function, that's just the cosine of x. There in red, we see the function that we're looking at here. Now as far as our amplitude, well, my lead coefficient is just 1. So my amplitude equals 1, no change there from the parent function. And then the period, well, the period is affected by b, which is 1/2 of x, or x over 2. And so let's see, the period then we defined as 2 pi over the absolute value of b. And in this case, the absolute value of b is 1/2, which we're then going to, as we simplify that, we take 2 pi times 2, the reciprocal of 1/2, and our period is 4 pi. Which means that if the frequency then is 1 over pi, 1 over the period, excuse me. So my frequency then is 1 over, the period's 4 pi, so it's 1 over 4 pi. All right, and now comes the phase shift. Now the phase shift, we can define the phase shift as c over the absolute value of b. It's negative c. Negative c over the absolute value of b. Now I will confess to you that phase shifts are actually hard for me to really spot and see on the graph. Maybe I just need better training at that, need to work on that. But algebraically, it's not too bad. In this case, c is equal to 1/4 because we got pi over 4. Well, I guess it's pi over 4. Pi over 4. And the absolute value, and this is negative, and the absolute value of b is 1/2. So let's see, now we got pi over negative pi. I need to keep that negative in mind. Over 2 times 2 over 1, and that's going to equal negative 2 pi over 2, but my 2's can cancel, and so my phase shift is negative pi over 2. And that's a horizontal dilation, so it's negative, so it means it's moving things to the right. And this is where it gets difficult for me to see. Well, maybe not. If I look at it right here, if I've got right there we're at 1, and right there we're at 1, let's say, and that would represent negative pi over 2, or my phase shift. Let's shift it this way, pi over 2. Okay. Like I say, it's always a little bit hard for me to see. This particular one is because that our b, which is 1/2 x, that expands this sinusoidal function, this cosine function, horizontally, makes it even tougher to see. But algebraically, I can prove that that phase shift is negative pi over 2. Let's look at one more. All right, well, this time we got a sine function, but we got 3 times the sine of 2x minus pi over 3. Well, my amplitude is based upon this coefficient, 3, so my amplitude is going to be 3. That's pretty easy to see. If you look right here, we go from the x-axis, we go up 3, and we go down 3. 3 from the midline, up or down. How about the period? Well, the period, let's see, what did we say it was again? It's 2 pi. Let's get period. Is 2 pi over the absolute value of b, which is 2. And so my period then just simplifies pretty easily to just pi. Now, what about my frequency? My frequency, of course, is 1 over the period. Let's see. Well, that would be 1 over pi. That would equal my frequency. Okay, well, let's see. Now to the phase shift. So the phase shift, again, is defined as C over, make a little better C, a little more like an E, C over the absolute value of B. Well, C in this case is pi over 3, and that is going to be over 2. And to solve this, this is going to be pi over 3 times, we're dividing by 2, which is the same as multiplying by 1/2. So then my phase shift, oh, I forgot my negative. But this is negative. This is negative, negative, so it becomes positive. This negative C up here. I almost always forget that. I don't know why. So that becomes positive. And what's my phase shift? Pi over 6. All right, well, we've just about thrown the entire kitchen sink at this thing except for one more transformation, and that's a vertical translation, which affects our midline, as we're going to see coming up next. And I know you can't wait.